we'll be back. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie! Whoopsies, I made a mistake and it's okay. It's okay! Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay! Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsie, 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 whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay! Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsie.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard, but for long, before it's too dark. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard, before long, before it's too dark. Wake up, my love, please don't give up on me.
What is up? What is up, you guys? Oh my, this is really loud. There we go. Our timer's a little delayed. We made some oopsies this morning, but it's because we're all thrown off. Look at that. Even my green screen is all messed up right now, alright? Because we got an earlier time today, earlier than normal. So everything's all messed up, alright? Probably some people that normally are here won't be making it today because I did kind of also forget to mention that we need to do an earlier time today, yesterday in the stream. Alright, all types of messed up today, alright? Well, luckily, we're going to record all this, alright? So everyone can rewatch it, but also see all the mess ups. Why is everything being messed up? Well, we had for the last 2 weeks, we have an event that's going on at 7 p.m. today. All right, we are going to be teaching Ghidra and how to use Ghidra. Ghidra is an application for reverse engineering made by the NSA's Research Directorate. It's super cool, super awesome, and 100% free. So we got a special guest who formerly worked for the DoD utilizing the application, and he's going to be teaching how to go about using it and all of its cool little features. But so we're just making room for that. Let me real quick fix this webcam if I can even figure out where it is. Oh, here we go. Ghidra is the reverse engineering thing, right? Yes. Ghidra is for reverse engineering, so any binaries you have, you can analyze and figure out what's going on and do some hacky wacky things if you would like. Where is, okay, hold on. Filtering. Where are all the filters? Gosh darn it. Just forgot completely how to use this dumb application. Can we open this? There we go. Alright, which one's the webcam? Is this it? No, is this one? There we go, okay. So let's look at that one. Here we go. Filters. Edit the filter. And let's see. Oh. Hello. Oh. There we go. That will do. That will do, donkey. That will do. Okay, there we go. Alright, let us continue here with our intro. Alright, let me switchy over here. All of the browsers. I'm new here, actually, but so most of the channel videos, and I am so interested. What's up? Nice, I can rewatch the old days, right? Yep, 100%. Thanks for joining in. Yeah, all the previous 70 days have been recorded. They are in the live section of the YouTube channel. Also, my screen's messed up, but that is because of what we were doing yesterday. So I'm going to keep it the same messed up because we're going to need that for today. So let's go ahead and finish up our intro before we go through any more questions. I gotta move this here correctly because it's like in a little mini part of our screen. There we go. Alright, if you guys don't know, we are a Rootkit nonprofit organization here in the US of A. We offer the industry's best comp sci certs. Why? Because we're the best in the industry, period. Don't go to college. Don't go to any other boot camp. They're going to charge you at the wazoo and give you a useless piece of paper. Come to us. Get your cert. You'll be better than any of them. We're going to teach you everything you're going to learn in college and more. And then you can get certified to go working at any job you want. All right? And we'll help you the whole way, because you can go take a look at the front page of our site. We're updating parts of our site because it's kind of lagging in information right now. But we'll help you with job placement, resume crafting, etc., etc. if you get a level 2 cert and higher. Some of those aren't with the level 1 certs, all right? And we do lots of things for free, like teaching everything you need to know to get the cert. So, on top of all that freeness, if you go over to our blog, we have our week 10 giveaway, which actually just ended. Actually, no, I think there's 2 hours left. There's 2 hours left, 1 hour left. So, go over here, click that green button, and just prove that you're subscribed to our YouTube channel, following on Twitch, just basic things like that, and you'll get entries to win the mystery gift. What's the mystery gift? I don't even know. We're going to figure out together tomorrow on our Chill Q&A stream, where we're just going to roll and figure out what we're going to be giving away and who's going to get it. We do these giveaways once every single week, all right? Once every single week. Additionally, doing things for free is kind of expensive. All right, a little expensive. Who's paying the bill? That's right, no one. All right, so we're losing money like crazy. So in the description of this video, and if you're on Twitch somewhere in the About Us, there's a link to the Streamlabs charity thing. If Streamlabs site wants to work here, always with something going array. All right, well, this site is working. You can see what it looks like on any of the previous days. You can donate to us. We are a charity fully registered here in the US of A, so all donations are 100% tax deductible. Avoid your taxes. I know what the gov does with them. They're just wasting it. They're burning it, all right? So avoid your taxes, donate, all right? Donate today. Additionally, all donations are being matched 1-for-1 for the first 10,000 donations. So every time you donate, it's like donating twice as much. All right. Also, depending on how much you donate, you can unlock certain rewards, like our epic stickers, our super cool t-shirt, or this exclusive 100-day of Rootkit sweater with the Rootkit logo on the back. It is extra thick, extra warm, and I sweat like crazy every time I wear this thing. I should probably wash it. It's been a little while. It kind of smells a little bit. All right. We have pillars along the way for our stream. You can see the little bar at the top there for how full it is. We have pillars along the way, like streaming for 24 hours straight. All right, get out of here. Streaming for 24 hours straight, shaving my head here live on stream, and the goal that no one wants to see, so the goal is not to get that goal, all right? And that's going to be shaving my beard here live on stream. No one wants to see that anyways, except for my mom, all right? We don't want to make my mom happy, all right? So we're not going to get there. All right, if you guys have any questions from the previous days or any new questions, go ahead and drop them into the chat before we continue with our journey about databases today. All right, databases. So let's check here. Wait, you're live on Twitch too? Yep, we stream on Twitch and YouTube, but the YouTube crowd is better, so screw everyone on Twitch. Are those certs known if I have them? Can I get a job with those certs? I am the EU. We have no partner companies in our first party network outside of the US right now, but you can 100% still get a job with them, and we will help you with your job applications. You technically can get dev jobs without any certification, without any degree. That's what I've been doing my whole life, except it's a pain in the ass. All right, it's not fun. That journey is very difficult. So we help you out. We streamline that whole process. You don't have to go around proving yourself as much. You can just get a cert with us, all right? Most people are able to get the cert from 0 to hero in about 6 months, all right? So 100 days, that's 3 months. Yeah, we're going through stuff very, very fast, all right? Most likely you won't be able to go straight after this and get certified. Additionally, all people that are chatting right now, so you're chatting here right now, we're writing and keeping records of everyone's name. So anyone that's watching during this event gets a waiver for the certification exam, all right? Usually $2.99. All get waivers to do it for free. And again, that comes with a bunch of services that you can see on our site that are listed there. And you can ask more questions on the Chill Q&A or in the Discord in the 100 Days of Rootkit chat. All right. 24-hour stream would be nuts. Yes, it would be. It would be fun. It would be like doing CQ shift all over again. All right. For the 24-hour stream, we wouldn't cover anything new. We would just be chilling, Q&A. I'd probably do some of my normal work so I can talk through like normal dev work stuff and how it looks and etc. Just depends on how much I can reveal, because I don't want to accidentally like reveal anything too sensitive on some of the projects we got, but YOLO, I guess you only live once. All right, I don't see any other questions, so if you guys do have any other questions, go ahead and drop them in. Additionally, one last thing, if you are a Patreon or Discord premium member, you can jump in the Discord. I am in the events chat here, so you can jump in here at any time, and Discord and premium members are able to chat, so you don't have to just sit there and type. You can just jump in and chat away. Alrighty, let us continue on. Again, I'm sorry for everyone that was expecting this to be at 7 p.m. and we did it earlier. All right, I'm sorry. I failed you yesterday. but it is recorded, so hopefully you forgive me. And this is going to be kind of a shorter day than normal because I want to make sure we're all prepped for the class later today, which I think a lot of you guys will probably appreciate because we've been going through things like a train. All right, so I'm going to pull up dbeaver because that's where we left off last time. So let's go ahead and get this thing loaded. I will check the website later and see what kind of certs y'all have. I'm already a C# web dev with 4 years experience, but I want to jump to the cybersec world. Epic, epic, perfect. C# is definitely popping the hell off right now. .NET is just growing in popularity, and Microsoft is doing a great job with it. So that's definitely good to have. Jobs are semi-limited because it's still a growing in popularity language because of a lot of the changes that .NET has made and the moves Microsoft's making right now, but it's definitely going to be growing and growing in demand. For the cybersec world, we focus a lot on secure development. We currently don't have any secure development certifications available. It's kind of just baked in our CompSci cert, but we can definitely help you with cybersec, like cybersecurity based certs like CompTIA, etc., like what pathway to take for that, because a lot of us come from that world and we are very familiar on what you need to do and what companies want to see. Alrighty. So we left off with our little database here with two tables, our user table and our, I'm gonna go and delete this blank new table here. So we got our user table and our tweets table, and we're kind of showing off how you can make those relationships and the power behind the database. And we talked about the speed, but we didn't really show off the speed. All right, we talked about the speed behind everything and how you can get, you know, that log of n speed on your queries when you're indexing things properly and you're using the keys. But we didn't really show that off. But also, I guess I didn't mention too much that you can do normal searches. So as if you were going to normally search through a text file and how it would be a log of n operation, you can do the same searches with the database. So just because something isn't indexed doesn't mean you can't do a search result off of it. For example, our time here. Let's say we wanted to get all tweets between, 1 a.m. and 2 a.m. You can totally do that even though there is no key. All right, you can totally do that even though there's no key. It will just be a slightly slower search. All right, and again, this is all relative when I say slower, because when we have 100 records, 10,000 records, even 100,000 records in our database, that's pretty small. All right, so you wouldn't really see any slowdown per se with that small of records. I'm talking more so like we're multi-million records, and I guess it depends on how big those records are, so how much data is in those. That's when you'll really see the performance benefits, because again, it's a log of n operation. If we look at our little pretty graph here again, so let's go to log n. Hopefully this brings up the same image last time that I really liked. Yeah, this one. You'll see this one on this beautiful site. They made this beautiful image. You'll see that the log of n, sometimes it will actually perform possibly slower when you're using log of n than just normal like searching, because it scales with the amount of data that you have. So the more data you have, the better it will perform, right? The better these optimized searches will perform. They don't really do that great initially on small amounts of data, right? You see the benefits in the long run, all right? So you're just setting yourself up for future success. Let's see. I hope my questions aren't bothering because I'm asking out of the topic you guys are doing now. I feel I'm lost and don't know the path that I need to take to work in the cybersec world. Yep, you can totally ask in the Discord and we can definitely help you out. Additionally, we do have that class today in 2 hours. So after this in 2 hours, because right now where I'm at, it's 5 p.m. at 7 p.m. So in 2 hours from now, we're doing the reverse engineering class. So you can definitely ask more security-based questions there, because that's what it's all going to be about. Additionally, there's the chill Q&A that you can ask on every Sunday is chill Q&A. So you can always ask questions there, and we'll help you out. All right. So we've talked all of this searching, etc., etc. How about see some of this in action, because we haven't really seen some of that. Before we do, let's add some more items here, because we only have one tweet and one user, which doing a search on that is not that impressive. So let's go ahead and add a bunch of bogus people in here. So if we go over to our script, where we can execute stuff, remember you can click this button to open a new SQL script. We can write SQL in here and then execute it. We want to add new stuff to the users database first, because you have to have users that then tweet. So maybe we don't remember what the script is. That's fine, right? Some of these things you can just always easily look up. Like if we right click on the users table and go to generate SQL, you can see there's the insert statement. Again, insert statement will be for adding new data. So let's click on that. There we go. That's what we need to do. Let's go ahead and copy it and then paste. No thinking needed. We just copy and paste. That's what the dev world is all about. Stealing. All right. So we're going to be inserting some data into public users. So we need the first name, the last name, an email, created time, and an IP address. So let's go ahead and just do a generic name here. So we'll do Joe Blow. All right. And then we'll do our email, jblow@google.gmail.overlords.com. All right, and then this is going to be some time, which is 2 numbers, colon 2 numbers, colon 2 numbers. That's the, or 2 digits, I should say. That's the format they're using. So this one, we're going to say like 010000. So at 1 a.m. And then I think we can just leave the IP blank. Let's go ahead and try to run this. And it added this person. So let's add another person, another user. Let's call this Tim Toe. All right, and he is at ttgmail.com, and his created time, let's say, was at 12. And then let's add one more person. All right, so we click on play. It ran right here. Let's add one more person. Let's add, I don't know, the Kate, Finn. There we go. All right, it's gonna be Kate at Ymail. Oh yeah, that's right, Yahoo Mail. I'm still surprised Yahoo's still kicking. All right, I'm gonna be honest here. And they made their stuff at 2000. All right, so we're doing 20. This is a 24-hour clock. All right, so let's go and run that, and you'll see. Or maybe it's not a 24-hour clock. Did I miss? Okay, maybe I lied. Oh, wait. Is it not? What? How do they know if it's AM or PM? Let's do this at like 8 a.m. and let's run. There we go. So if we go back to users, remember sometimes you'll have to click the refresh button here at the end. So if we click that, we can see all our users are made and in here. And I guess we didn't. No, I think we made this column after the fact. All right. So any questions so far before we move on? All we did was create a bunch more users with just generic data. You can do whatever you want. And you can see that ID column is auto incrementing, unique for every person. So we don't need to worry about that, but that's a great, reference to know who is who. Let's see here. Brilliant. In 2 hours, I'm definitely in. All right, I'll see you then. Any other questions? All right, I don't see any other questions, so we're going to go and chug along. We can now start doing searches on the users table because we got some more data here, so we can be specific on what we want to search by. So let's go ahead and go back to our script here and let's do some searches. All right, so let's erase that. What if we don't know how to do searches? Well, you can go do some Googling. All right, there's also that right-click generate SQL we can go peek at. Maybe it has something for us doing searches. Now, when you want to search for data in a SQL database, the query for that is going to be select. All right, select, not search, but select, because you want to grab or select some data. What that data is, you have to determine, but you tell and make a request to the database that you would like to select something, and it will perform the search automatically for you. So for example, if we click on our select syntax, it will auto-generate some select syntax here for us. So let's go ahead and copy and paste that and take a look at it. It says that we want to select the first name, the last name, the ID, email, the ID, the created time, and the IP from users. Interesting. So this is going to give us all the data that users have. But what user? I don't know. Will this even work? I don't know. That's the thing about programming. Just try things. Just try, just attempt. That's why we play that whoopsie song, because it's okay to make mistakes. It's okay to mess up. Just try, and fail. All right? You should be failing a lot. You're not being a proper dev if you're not failing a lot, all right? That or you're just a genius, all right? Most likely you're not a genius. I know, I'm sorry. I'm not your mother. I'm not here to make you feel extra good about yourself, but look, I'm not a genius either, so it's okay. We're in the same ballpark. I mess up a lot. All right, so let's go ahead and click on the play button here, and you can see some magic has happened, right? Some magic has happened. We now see a bunch of data here. What data do we see exactly? All of the users. So the statement that it has created for us will get all of the users for us automatically. So select is basically all of the columns that you potentially want to select. And where do those columns belong? Because these columns may be columns from the tweets table. How does it know? Well, from this from section. The next section here, from, tells us which table to grab these from. So you can be very selective on this, and the order does not matter, right? The order does not matter. Even though this is the order they are in our database, you can flip this order around. So maybe I want ID first, or maybe I want ID at the end here. If I put ID at the end here, and maybe I want last name after that, all right? Maybe I want last name twice. If I rerun this, you'll see that it just does it. All right, it will return these items, these columns, to us in the order we request, and it will even duplicate columns, right? This is really useful if you want to minimize how much data you're searching for and returning, because again, this could potentially be a lot of data. And so you may want to only return the columns that you really need in order to minimize the amount of data, because typically a database will be a server on a separate computer that you're talking to across the network. Keyword there, the network. The network is usually going to be your biggest bottleneck. So you want to make sure you're not clogging it up with a bunch of excess data you don't need. Make sure the rule of thumb is keep your queries as small as possible whenever you can. So if all I needed here realistically was just the ID in the first and last name, I can just ask for the first, last name, and the ID, run this, and I'll get all of the users' first, last name, and ID. So I've shrunken my query, what it returns back, and now I am saving bandwidth across the network. Additionally, sometimes you may have like 100 columns, all right? It's not unheard of to have a database with like 100 columns. It would be really annoying if you had to put in your script here 100 different names, all right? I would lose my mind. So what you can do instead, if you want to grab everything, you can use the asterisk, all right? Asterisk is your all command. So select everything from public.user. So if we rerun this, you'll see that it's not going to work. Why are you not going to work for me? At least this is valid on MySQL, but I guess maybe not for Postgres. Okay, never mind. It's working now. Okay, it changed its mind. All right, it changed its mind. So it's working now. Hey, these things, man, computers, they're a pain sometimes. All right, sometimes it works, sometimes it doesn't. Who knows? All right. So you can see it works. I did asterisk. That's for selecting everything, and then we get everything automatically. All right, but this is cool and all. What if I don't want everything? What if I only want one specific user? Maybe Tim2 over here is who I want. How do I go about getting Tim2? Great question. There's nothing in here that we've seen on generating scripts, these scripts for us that will really help us, right? Because it generated this select statement, which will just give us everything. We don't want everything. We just want one item. So how do we go about doing that? Well, this is where you might need to do some Googling. And when you do some Googling, you'll figure out that there is a special word called where. And your where follows kind of like an if statement logic, conditional logic that you can use for finding things. All right. What does that mean? Well, we'll refresh your memory here in a second, but you should be starting to get comfortable with these terms like conditional statements, all right? Because we've used them a lot. We've shown lots of examples with if statements. Before showing that real quick though, just so you guys know, there is a semicolon right here. Why is there a semicolon right here? This is kind of like C, right? Remember C? We talked about it for like a week, in the sense that it's not white space sensitive. So you can have this on as many different lines as you want. All right, the spacing does not matter, right? I can have this query look like this, and when I run it, it will supposedly work. I think I think the spacing for this one is selective. With no table specified is not valid position. Okay, I guess maybe it's semi-picky. The big point is it's not very picky. The semicolon is what tells you what is the end of the line, because you can have all of this as one big line. So if we do it like this and rerun, there we go. Now it works, right? Now it works as one big line. So this is the end of the line, all right? People usually will put these on a bunch of separate lines because it just looks nicer, all right? It's easier to read. So if we rerun this, it works just fine. It's just easier to read. So SQL has a couple different steps to it, right? Usually there's always going to be a command up front. Let me start over with it. A command up front. You've seen some of these, like select. If we look here at generate, you'll see some of the other ones like insert and update or delete or merge or some of these other ones, all right? That will be first. And usually what follows it is maybe the columns that you want to affect. It always depends, all right? But that's usually the typical syntax. Then there will usually be a from that follows. A from that tells you what you are going to affect, what table you want to perform this logic on. And then after that, you can then be more specific using a where, all right? A where. Now, for your SQL statements, you'll usually see these all in caps. Why didn't it auto cap it? Select. Do I have to click on it? It still lowers cases it. Usually you'll see it all in caps. These special words all in caps. You don't have to have them all in caps. You can have them lowercase and they will work just fine. All right. It's preferred to have them all in caps so you can be very visually clear that these are the pre-built commands for SQL and not your normal typage for your table names or any other logic you want. All right. So where is how we can do conditional logic, like our if statement logic. Where is where we can put literally if statement logic after it to figure out how we want to go about searching or finding stuff. So where can be specifically selecting one item, or it could be selecting a range. We'll show all those examples here in a second. For example, in this one, we want Tim2. So we want to select everything about Timto from the users table and we want to do it based off of what? Well, ideally the ID for multiple reasons. One, it's unique. Two, it's indexed, which means we get higher optimized results, right? Because it's going to be quicker on the lookups. So where ID potentially equals 3, right? Where ID equals 3, because that will be this line right here. So we can actually just type that in, where ID is going to be equal to 3. We don't need 2 equal signs, right? Because 1 equal sign in normal programming is going to be your assignment operator, but you can't really have variables in SQL scripts. You can in certain conditions, but not really. So 1 equal sign is all you need to do, and that will be your comparison operator. So where the ID field is equal to 3. And if we run this, you'll see that we get Timto here, right? We get Timto. And usually it will show the time. So you see right here, we got our results in 0 milliseconds. So pretty much immediately, right? There was no delay at all when getting this record. Because we were, again, the table's small overall, but we were also searching on the ID, which is highly optimized for our results. So you can mess with this. You can say maybe we want of ID 2, and we rerun this, and now we get Joe Blow. All right, this works on every single field. It doesn't just need to be the ID field. So we can say something like we want everything about a user where their first name is equal to maybe Joe. So we got to put these in quotes because it's a string. And if we run this, we're going to see we get a beautiful, beautiful error. So maybe it's not double quotes. I think it's just single quotes. And let's rerun this. There we go. Single quotes works. And now we get the record of Joe. This would be an issue though, because if we had multiple Joe Blows, we're going to get all of their profiles. We don't right now. So let's go ahead and show that issue off. Let's add another user. All right, let's add another user here. So if we run our insert command, so let's go ahead and grab that by right clicking on users, going to insert, copy, paste. Let's add another Joe Blow. Let's make his email slightly different. So J Blow at .com. All right, and his time was maybe 10 minutes and 0 seconds. And let's go and run this, and we just added him to the database. So now when we do our select statement, so let's do our select everything. We want all the information we got from the users table, which is going to be public.users, where our first name is going to be equal to Joe. And I can't use double quotes, so let me go back to single quotes, Joe. And if we run this, now you'll see we get 2 results. We have 2 different Joe Blows on our service here. So if we were to do something like this, it would not be very useful for us, because we wanted maybe the one with ID of 5, but we got both of them. So this is why it's best to use the IDs, because the IDs are going to be unique and different for every single person, so you can tell the difference between multiple people with the same names. All right. So if we change this, well, we can show off compounding logic, right? Compounding logic, because again, this is just a big conditional statement, right? And to make it look a little bit better, we can put that on a new line here. And then we could do something like and, right? And, like Python and. So this is our conditional logic with an and statement now, with an and statement. So we want the first name Joe, and also that has the ID of ID equal to 5. This is not a great query statement to make because you could just remove this first part and just do ID of 5, but the point of this is to show you can use AND logic and you can use OR logic. All right, you can use and OR logic. So if we run this, you'll see it works. Right, see it works just fine. I spaced it out like this because it might be a little bit easier for you to understand, but you could totally have this all on the same line because it's not white space sensitive, like I said before. And if we rerun this, it works just fine. And now you can see we got the one Joe Blow we wanted, right? The one single Joe Blow that we wanted. So you can be as complex with your logic here as you would like, all right? And it's not just equals to you can also do not equal to. So I want users with the name Joe, and they can't have the ID of 5. All right, they cannot have the ID of 5. So if I rerun this, you'll see we get our other Joe with the ID of 2. All right, so you can do not equal to. All right, so one equal sign is going to be your equals to, which is in most programming languages the equivalent of 2 equal signs. And then we can also do not equals to with the exclamation mark. We can also do things like greater than, less than, greater than or less than, greater than, less than, greater than or equal to, or less than or equal to. All right. So we could do, maybe we want to find people based off their, when their account was created. So maybe we want to do searching based off their created time, when their created time was greater than or equal to, let's say at, I don't know, let's do 08 00 00. So this will return, this is a big search that will happen that will give us all of the data, all of the users who created an account after or at 8 o'clock. After or at 8 o'clock, because the created time needs to be greater than or equal to 8 o'clock. So if I run this, you'll see we get a beautiful, beautiful error here. Though, what is the time error for? Syntax error equal to near this. Let's go to time here. I did the same format. Why you gotta do this to me? Do they want this one to be? Please don't tell me this one is supposed to be. No. Does it just want it to be num? This doesn't even make any sense. Why would I want it like this? Can I just do this? Sorry, y'all. I don't really mess with Postgres too much. So I'm not really too familiar with this. So let's change this instead from created time to something else like our IDs. So we want everything above an ID of 3. So let's go ahead and do ID. So they must have an ID that is greater than or equal to 3. So if we rerun this, you'll see we get 3 results of ID 3, 4, and 5. We get everyone with ID of 3 or greater, right? Of 3 or greater. Additionally, we can do compounding, like I said before. Is there a time command that we need to function? That's going to bug me a little bit. We could search it, but it's all right. We'll move on for now. This works with this works with the parentheses, right? With parentheses. So let me go and put something else here, like last name is equal to Finn. All right. So this now should return Kate to us. So if we run this, we'll see Kate is returned. This additionally allows you to put parentheses to make sure certain logic, fires off before others. So you can put parentheses in this and then rerun, and you'll see it works just fine. So just know, just like if statements, you can use parentheses, all the conditional logic we've talked about, ands, ors, to, form exactly what you want. And it's beautiful, and it works like that. It works almost like magic. Now, there are more powerful features built in the database for doing searching. These are like the basic ones that should work for most of your use cases. There are also features that are typically built in for doing searches based off maybe geodata, so the Latin log data, maybe doing circles. So if you want everyone that's like within a radius of 50 miles or 50 kilometers for everyone watching outside the US, you can get really complex with these searches. And let's see, yep, here we go, radius and radians. All right, there's a lot of pre-built baked in features. All right, one of the more powerful ones for early on users would be, might want to make some more users here, would be the like statement, right? The like statement. So where last name is like, and then we'll do an F and run this, and let's go look up the like statement real quick so I can refresh myself. Here we go, SQL like. I thought I did put the pattern in. Okay, it wants the percent sign. So if we do that and then percent sign and then run it, there we go. So like is really nice because it kind of is a autocomplete search for you, right? In a sense, an autocomplete search. Just kind of like how Google tries to autocomplete what you're typing. This allows you to do kind of that same functionality where you can search for someone, maybe everyone with the last name starting with an F. This will get everyone with a last name that starts with an F. Additionally, you can do a lot more functionality with it like this. You can find any values that start with a letter. So A and then parentheses will do everything that starts with a letter. Anything that ends with a letter, so you do the parentheses at the front to get everything that starts with anything, but it needs to end with an A. Find any values that have or in any position. All right, so you can do percents on both sides to do a wildcard. So that might work better for our use case here. So let's see, we got O, 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 and O. So we got 3 last names here with O's in them. So if we wanted to get all of the last names that have O's in them, we could use that one that we just saw where we do percent sign O, percent sign. This will get us all last names with the letter O in it. So if we rerun this, you'll see, there we go. We got all last names with the letter O in it. Let's check out the rest of these. So there's underscore that you can use also, which is a special key, finds any value that has an R in the second position. All right, so the second position. So an underscore is going to be specifically saying this is a wild card, so it can be any character, but there's only one character that's allowed to be in front of this. All right, same thing with this. You can do it afterwards. All right, so finds any values that start with an A and are at least 2 characters in length. Find any values that start with an A and are at least 3 characters in length. Find any values that start with an A and ends with an O. All right, so there's lots of functionality you can get out of like. All right, that's probably one of the more common terms besides the default conditionals that people will be using the database for. All right, so this is an extremely powerful thing you can do, and guess what, it's pre-built in. It's a built-in feature that you get automatically when you use a database. It's optimized. It's as fast as you can possibly get it. You don't need to make it from scratch. You don't need to do searching in your program, because if you made a text file and you were storing all your data in the text file, that could be your database and you can search through it. But you may not get these epic, powerful functions without making them yourself from scratch, which you get by default when you use a database, right? Which is really, really cool. And I guess I should specify when you're using a SQL database, right? When you're using a SQL database. Any questions so far before we continue here? Wait like 30 more seconds to see if there are any questions. And again, remember you guys, tomorrow's our chill Q&A. So if I did bamboozle you because you thought today's class would be at 7 p.m. and you do have questions, please tomorrow come ask them, and you can come chew my head off a little bit, all right? For forgetting to fill you guys in on the time difference. I'm sorry again. All right, so let us continue. Select is kind of one of the last big pieces for us. And select has even more functionality than we showed off so far. Because, for example, what if we want to look at the tweets? We can use a select statements to get tweets, all right? So let's go ahead and rework this. So let's get all of the tweets. So select everything from public.users. No, we want public.tweets, all right? So we type in here tweets and we rerun this. There we go. We got all of our tweets here. But a little bit of an issue, right? We don't know off the bat who user 1 is. So do we need to make another select statement here where we say select everything from users where ID equals 1? And if we rerun this, all right, now we got the user right here. All right, well, this is hard coded now. What if the tweet was for someone with the ID of 3 or something? So that doesn't really work either. All right, what if there was a way for us to kind of combine these together? I wonder if there's a way to do that. So like, you know, when I say combine, I mean, you do this tweet and then you can combine or fill out this user ID information, and you're in luck. There is a way to go about doing that, right? There is a way to go about doing that. Hi, you using Linux? No, I mean, you can use Linux, you can use Mac OS, or you can use Windows. I'm on Windows. So, there is a way to combine these queries, and that's the power of the relations in these queries. So instead of you having to do potentially multiple queries to get, you know, the tweets and then combine that information with the user so you know which user did the tweet, you can do all of that functionality at once in one big SQL statement, right? One big SQL statement. And we can do that utilizing the union, right? Union operator, or you can use join. There's a bunch of them. The W3 School site is really good for your SQL tutorials, so I highly recommend going through this. If you guys want, then you can go check out everything in here. All right, but you can use something like a union, which is a union operator, which we talked about back in basic math, which you guys hopefully remember some of those because it's all applicable when we talk about logic. All right, all applicable when we talk about logic. So the union operator works exactly like we talked about in our basic math section, all right? So we can go over here and we can potentially make bigger select statements where we add 2 tables together. So select everything, all the columns from table 1 and add them to all the columns in table 2. So let's try to mimic this syntax here, right? Let's try to mimic this syntax here. I think this, yeah. There has to be a commonality between them, aka the how both of these have a city. They have to have something that's common in between them, which we do, which is going to be our user ID. So if we do select, and I think we can do this comma ID, right? Let me run this and try it. Yes, we can. All right, so select everything, and then we're going to have the ID at the end here. And then we're going to perform our union. All right, and then we want to select everything. And this one's going to be the user ID, and this one's going to be ID, and this one's going to be our users. And if we run this, you must have the same number of columns. Okay, then I think it's the join we have to do, because it's saying that we need the same amount of columns for the union here. I think there's a way to get around that, because that doesn't seem, no, the number of columns. Do we need to do just this and rerun? There we go. Let's see here. That's not what I want. We definitely need a join for this one. So let's go ahead and go over to joins. All right, union's not going to be our solution for this one. Join cause is used for combining rows for 2 or more tables based on a related column, which we have, right? We have a related column, and here it is, customer ID for their example. Orders come in, orders are on the order table. They have an order ID, a customer ID, which links it to a customer, and the order date. That was quite some time ago. All right. And then we have another table called customers, where they have a customer ID and a customer name. This is quite similar to our setup right now, except instead of customers, it's users, and instead of orders, it's tweets, right? But it's the exact same concept. So we can do something potentially here like a inner join, where we say select, and then we have to specify the table dot, then the tables column, all right? And we can combine both of these together, and then we say from, and then inner join, and then telling it where to join on, right? Where to join on. So we want everything to be combined together, where the customer ID is equal to the customer ID. Just join Discord, wondering why you were here talking to yourself, and here you are. Yeah, no one really joins. Oh, look at that, Void's over in the Discord right now. You not too many people usually join the Discord events chat. But yeah, everyone's here on Twitch and the YouTube channel. Today's kind of lower on the view rate because last minute time change. So all the normies are not here today, right? Because they're most likely going to be mad at me. But it's all right. Everything's recorded. So this is a great base for us to use, right? This is a great base for us to use. This may not fit exactly what we're trying to do exactly right now because we don't have orders or customers, but we do have users and we do have tweets. So what we can do is use this as a base, steal it, and then modify it, because that's what half of development is stealing and then modifying. All right, so let's go ahead and steal this. Let's go over here to our SQL statement. Let's put this at the top here just as a reference, and we can go about modifying our statement here below to try to do this join, right, on our data. Also databases, am I right? Yes, we are currently going over databases. This is day 2 of SQL databases in particular. I think tomorrow we might be hitting, well, tomorrow's chill and Q&A, so there's nothing new tomorrow. We're just answering questions. But the day after that, so Monday, most likely we're going to be going to NoSQL databases. We'll see. All right, so we can see here we got order.id, customer name, order.date. So this is basically all of the columns that we want to combine together. I believe we can just do an asterisk and get everything and then combine everything together. We'll see here in a second, because again, programming is all about trying stuff, right? We play the Oopsies song a lot. Every single day of 100 Days of Rootkit, we play it because you guys need to be failures. You need to be the biggest failures in the world, right? You should be trying stuff and breaking and failing all the time, right? That's the only way you can learn and experiment. So I don't know if the star will work here or not, but we're gonna try it. If we fail, it's all right. We can go and type out this big thing by hand, all right? But why not just try? So next we need a from. So let's do our from. Let's remove this section here because the from is getting all messed up. We need that semicolon. So we need from, and this is orders. Well, we know we're doing tweets, so we'll just say, I don't know, public.tweets here. I think just doing tweets itself might work. I think the more proper way is is doing public.tweets. So that does work. So the more proper way would be doing public.tweets, but just doing tweets by themselves will work. All right, so let me uncomment this. So far we got everything correct. Select all, which gave us all the columns here, but only from the tweets section. All right, we don't want just the tweets. We also need the user information. So that's what this last part is here, in here for. So we can do an inner join on our users. So that's going to be public.users on, and where are we going to join them on? Well, we have the user underscore ID in tweets, and in users we have the IDs. They're just called IDs. So we can join there. And this is just a normal logic statement, an if statement, or a equals statement. As you can see, just is it equal to that? So here we can do our public dot tweets dot user ID is equal to public dot users dot ID. So we want to get everything, all right, from the tweets. And when we get everything from the tweets, we also want to match the ID, the user ID here, with the corresponding user's information. So if we run this and we're successful, we should now no longer see just a 1 right here for the information of the user who made this tweet, but we should also see all of the user's information. So if we run this and we get that beautiful, beautiful error on for orders, we have, why is there from table orders? I think it's missing. I commented that out. Okay, let me delete this because it's getting messed up on it. There we go. There we go. Look, we got a big table here. All right, lots of new information. Now you can see here that we have our original tweet, but the user, that is user ID 1, is now attached to this tweet's information. So in one single SQL statement, again, you don't have to compress your SQL statements. You can do a bunch of individual statements, but again, databases are usually going to be on a separate computer that you will have to communicate to over a internet connection, all right? Which means that's your biggest bottleneck when you're having to send data, multiple requests across that wire, and then wait for multiple things to come back. It's really, really slow. It's going to be faster if you can combine it in one big request, send it off, then get one thing back, and there you go. All your data is just laid out. Additionally, when you send a bunch of requests out and get a bunch of them back, you still have to do that stitching up process, all right? It's still going to be separated. You still have to stitch it up. But here, when you do this, the database is going to do all of that stitching up for you and just return to you one big record with everything you want. So there's a lot of optimization here that you can utilize, and a lot of pros that you get when you do look at the unions and join statements, all right? The unions and join statements, all right? And you can see there's a lot of them, like inner join, left join, right join, full join, self join, all right? So take a look here and go through the W3 School site and check out all of these, because they are all very, very useful. They're all very, very useful, and they're not that complicated to utilize. As you saw here, we just copied what they had as their example. We modified it to what we're doing, and we got it to work here. And we got it to work here, which is super, 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 super cool and handy. Additionally, it kind of looks simple because we just have one tweet. Let's add a couple more tweets and kind of see the real power we get here as we move forward. Any other questions? If you have any other questions, go and ask them. I'm going to do this one last example, and then we're going to call that a day, because we do have that reverse engineering class here in about an hour, right? In about an hour. So I'm going to finish up with this, so that way that will leave lots of time for prepping for that reverse engineering class here in an hour. So if we go to our tweets here, we can right click, generate SQL, grab our insert. We're going to copy this code, and Please let the comments work this time. Let me comment this out, and we'll go up here and put our inserts. So let's go ahead and make some more tweets. All right, let's call this tweet "Hi Mom." All right, and our time we'll just do 000000, and this we'll do user ID 2. Who that is, I don't know. Let's just make it. All right, that was made successfully. Let's make another tweet here, and let's just do some random text. Let's make this of ID 5. Add that. All right, and now let's do something else. Tacos, and let's make this also of ID 5. So someone tweeted twice. All right, there we go. We just generated a bunch more tweets. Now, when we do our select statement here again, you're going to see that we get all of those tweets and all of the associating user information is next to them, which is super awesome and super powerful. Additionally, this is why you don't want to have all this information crammed next to each other, because you can make tweets where you put the actual user's name and etc. here in the columns, but it's really bad if you do that. For example, what if I decided I typed in my name wrong, or I changed my name? Maybe your last name changed. If someone changed that information, now all of the information you had on the tweets here would be wrong and incorrect, and you would have to modify all of them. But since we used relations here, we get write once, work everywhere perfectly every time. What do I mean by that? Well, if we look here at our select statement again, we have the two different Joe Blows here. They've been tweeting a lot, all right? Joe has a lot to say. Let's say Joe Blow number 2 here, all right? You can tell they're different because their ID is 5 and this one is 2, but additionally their email is different, all right? Let's say Joe Blow here just had his last name changed, right? Just had his last name changed. So since we did everything using relations, this is super easy. You just, in the users table, change his last name. So instead of Joe Blow, he's now Joe Walb, all right, Joe Walb. And we just going to save that. So Control S to save that change. And now when we run our select statement, look at that. All of his last names here have completely changed because we're using that relation. We're getting all of his information from the users table. The users table is the one master record that everyone will look at when looking at user information. So again, we change it once here and it just works everywhere. All right, that's the super big power play of using SQL databases and setting up your relations properly. And it, you're getting the speed, you're getting this optimization. There's just so many pros. There's so many pros to this. Any questions on this before we end today's stream, right? Any questions on this before we end today's stream? Additionally, tomorrow we have our chill Q&A. So you guys can join in for the chill Q&A tomorrow. It's just any questions from the last 70 days that you guys can ask, and we'll go about answering them, etc., etc. I'm gonna wait a little bit longer to see if any other questions roll in. I'll figure out what we're going to do on Monday, because I don't know if I want us just to go straight into NoSQL databases or whether we want to show using this in code a little bit before we switch to NoSQL. All right, I'll figure it out either later today or tomorrow. So for you guys' challenge, right? For your guys' challenges, use this. All right, go on to the W3 School site and check out all of the joins and the unions and mess with them. Mimic what I did here. Mess with them. Make maybe more tables. Try to maybe figure out how to combine 3 tables together, right? 3 tables together, because we're only showing 2 tables right here. All right, so go just mess with it. That's the only way you're going to learn with all this practical information, because I think day 40 something is when we finish with the book work stuff. All right, that's going to be just the memorizing of the terms, and that's what you'll be potentially quizzed on. Everything since that has been practical information. The only way you're going to learn this is by doing it. You're never going to pass the practical if you're not doing this stuff and practicing it, all right? It's not the practical section of the exam is not a question and answer. You have to do these things in a very limited amount of time. So if you're not doing this on your free time, you will not pass the practical. You will not pass the practical, all right? All right. I don't see any other questions, so we're going to call that good for today. And a reminder, we do have in about an hour the reverse engineering course that you guys can ask. All right, that's all I got for you guys on this one, so I'll see you guys tomorrow on the next one.